And now we come at the trigonometry. So first it asks us to state the quadrant where we would find 215 degrees. So one thing that may be helpful for you is actually kind of draw the coordinate plane just like this. And we're dealing with degrees, so we'll do 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then 360. And this asks for 215, which is in this area because it's between 180 and 270. And that is quadrant 3. Remember, it's quadrant 1, 2, 3, and 4. So since 215 is between 180 degrees and 270 degrees, that means it is in quadrant 3. Question 19 is very similar, but it is dealing with radians. And we're dealing with negatives. So radians will do 0, and since we're going negative, we'll come around this way. This will be negative pi over 2, or negative 1/2 pi. This will be negative 1 pi, negative 3/2 pi, and then negative 2 pi. If it's helpful, think about this as a fraction. Another way you could write negative pi over 4 is negative 1/4 pi. Okay, now negative 1/4, just like you can think about this as negative 1/2 pi. So it may be helpful to just think about the fractions. Negative 1/4 would fall between 0 and negative 1/2. So that means it's in this quadrant because it's between 0 and negative 1/2. So again, quadrant 1, 2, 3, and 4. So it is in quadrant 4. Okay, list at least one positive and one negative coterminal angle for 510 degrees. To find coterminal angles, you can add 360 or subtract 360. So for 510, we can add 360, and that gives us one of the coterminal angles. Sorry, my computer's running a little slow here. I think 870 is what that one will give you. Now you can also subtract 360 from 510. Now if you notice, that gives us actually just another positive coterminal angle. That's fine. You can use either one of those as the positive coterminal, but to get the negative one, we're going to have to subtract 360 again. You can actually add and subtract 360 as many times as you want to get coterminal angles. So for the positive one, you can use either 870 or 150. Both are fine. And then for the negative one, negative 210 degrees. 21, we're told to convert the angle measure from degrees to radians. So we have 330 degrees, and we're asked to convert it to radians. To do that, we multiply by pi over 180. One thing I said in class was you always take the one that you want. We want radians and put it on top. Pi is in radians. I never really write the unit, but that is pi radians. So the one you want to get goes on top. So we get 330 pi over 180, and we can reduce the 330 over 180 part. So let's just type in 330 over 180 and change that to a fraction. So we get 11 over 6, or 11 pi over 6. Now we're doing the reverse direction. We're starting with radians and converting to degrees. So since we want degrees, we'll multiply by 180 over pi. The pi's do cancel out, so we just get negative 3/4 times 180. And that gives us negative 135 degrees. Make sure to include the negative there. Okay, now it tells us to use the triangle picture to find the values of these three trig functions. Okay, first thing we might notice is that we are missing this side right here. To find that side, since it's a right triangle, we can use the Pythagorean Theorem. So I'll just call that side A, doesn't really matter. A squared plus 8 squared equals 13 squared. And it is important to put this one as the one by itself because it is the hypotenuse. The hypotenuse is always the one that goes by itself in the Pythagorean theorem. So we'll solve that. A squared equals plus 64 equals 169. Then we'll subtract 64 from both sides, get 105, take the square root, and get the square root of 105. You can put the decimal, but I'd prefer you just leave it as the square root of 105. Okay, now, given we're looking at this angle, we can label each of these sides. This is the opposite side, this is the adjacent side, and this is the hypotenuse. So when we're looking for sine, we know sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And tangent is the opposite over the adjacent. Remember, some old horse caught another horse taking oats away, or some old hippie caught another hippie tripping on acid. Next, use the picture at the right to find the value of y. Well, we're going to use trig here, meaning sine, cosine, or tangent. We have this angle, and this is the adjacent side, and this is the hypotenuse. So given that we know the adjacent side and are trying to find the hypotenuse, cosine makes the most sense because the cosine of 58 degrees is equal to the adjacent over the hypotenuse. So we'll multiply both sides by y, and then divide both sides by the cosine of 58 degrees. And we can type that in our calculators. We get 61 over cosine of 58 degrees. Okay, I think I'm in the wrong mode. So let's go to the mode. Should be in degree mode. Let's try that again. There we go, 115.11. So y is equal to 115.11. Okay, 25, similar problem. Find the value of a. We have this angle, and this side is the opposite. This side is the adjacent. Opposite and adjacent deal with tangent, so we do the tangent of 70 degrees is equal to the opposite over the adjacent. So we'll multiply both sides by 13. We'll find a by doing 13 times the tangent of 70. And we get 35.717. Okay, same type problem here. We've got an angle. We know this is the opposite, and this is the hypotenuse. So we'll use sine. We use sine of 31 degrees is equal to the opposite over the hypotenuse. Multiply both sides by 8.2. Then let our calculators do that hard part. And we get 4.223. Okay, now we've got to figure out all the parts of this triangle. Well, we can go ahead and see angle E is 90 degrees. That's what that box means, as I'm sure you know. So we can go and put 90 degrees there. They tell us that side F is 5 and side D is 11. So we can figure out the third side, side E, by using the Pythagorean Theorem. We can do 5 squared plus 11 squared equals E squared. And we do it that way because we know E is the hypotenuse. So we solve that. 25 plus 121 equals E squared. So we get 146 equals E squared. Take the square root. Okay, so we now know E is the square root of 146. And we have all the sides, so we can start solving for the angles. It doesn't really matter. You can solve for D or F next. You can choose. I'm going to pick D. It's best to use this side and this side because we know them exactly. This is the opposite. This is the adjacent. So we can use tangent to help figure this out. So we do tangent of angle D is equal to the opposite over the adjacent. And we can use arctangent or inverse tangent to solve this. So we'll do arctangent of 11 over 5. And we get 65.56. Well, now we know two of the three angles because we know this one and the 90-degree one. So the quickest way to figure out the third is just do 180 minus those two. And we get 24.44. So we have used trig and the Pythagorean theorem to figure out all the sides of this triangle. Now we get to draw some pictures. So we start with a kite that has a string that is 70 feet long. So here's the string, it's 70 feet long, and that's at an angle of 67 degrees. So the question is, how high is the kite from the ground? So the kite's up here. And we want to know how high it is off the ground. So this is very similar to the ones we were doing a minute ago, where we just need to set up a trig problem. We just had to draw the picture to help us see it. So here's the angle. This is the opposite side, and this is the hypotenuse. That tells us we need to use sine. Sine 67 degrees is equal to the opposite over the hypotenuse. So we'll just multiply both sides by 70. And we get 70 sine of 67 degrees. And we find out the kite is 64.435 feet above the ground. Now we have a tree that is 15 meters high. So a tree 15 meters high, and then it has a 12.3 meter shadow. Okay, the shadow is on the ground. We're not measuring a shadow through the air. So the shadow is what's on the ground. And they want us to find the angle of elevation, meaning you need to find this angle right here. Now, given that we're looking at this angle, we know this is the opposite side. All right, give me just a second. Try to crack this computer going on. It's having trouble. Okay, let's see what it's doing now. Whoop, all right. Believe it or not, that's a good sign. Okay, now we know this is the opposite side, and this is the adjacent side. So that tells us to use the tangent. So tangent of this angle we don't know, we'll call it x, is equal to the opposite over the adjacent. So to solve for that, anytime we're trying to solve for the angle, we need to use arctangent or inverse tangent. So we'll do second tangent, arctangent, of 15 over 12.3. That tells us that the angle of elevation is 50.648 degrees. Okay, now we're dealing with the law of sines. Just a reminder, this is what the law of sines looks like. So we can fill in what we have here. Sine of 19 degrees over, we don't know side A, equals sine of 103 degrees over, we don't know side B. Sine of angle C, and we actually can figure out what angle C is equal to because we know the three angles have to add up to 180. So if we just do 180 minus 19 minus 103, we get 58 degrees over side C, which we do know is 47. Okay, from here you can cross multiply. I'll just choose to do these two. You can cross multiply. We get B sine of 58 equals 47 sine of 103. And then divide both sides by the sine of 58. That will give us, once we plug it in, side B, which I'll just tell you once you plug it in, you get side B, which is actually what I asked for. I'm glad that's what I did. You get side B is 54. So side B is 54. Okay, now we do the law of cosines. Given the following measurements, use the law of cosines to figure out all the sides and all the angles. Well, if you notice, they give us all three sides, so we're going to have to just figure out all three angles. Remember, if this is true, that they give you all three sides, you need to solve for the biggest angle first. And the biggest angle always goes with the biggest side. So that tells me to use this version of it right here. So I'll do 20.1 squared equals 7.5 squared plus 17.9 squared minus 2 times 7.5 times 17.9 cosine of C. Okay, remember, you got to make sure you simplify correctly here. The 7.5 squared can be added to the 17.9 squared. You get 376.66, and we'll go and do the 20.1 squared, 404.01, and then this we can combine, 2 times 7.5 times 17.9, and get 268.5. But it's important to remember that we cannot combine this number and this number because the 268.5 is attached to cosine C. So they can't be combined because one has cosine and one doesn't. So instead we'll subtract, I'm not dividing, I was just underlining, subtract 376.66 from both sides. So we get 404.01 minus 376.66. So 27.35 is equal to negative 268.5 cosine C. So then we'll divide both sides by negative 268.5. We get negative 0.101 is equal to cosine of angle C. Again, to figure out the angle, we need to do arc cosine or inverse cosine of that number. Use that exact number by using the answer key, and we get 95.85 for angle C. Alright, so we have one of the angles and it is the biggest. Once we do that, we need to switch over to the law of sines. So we'll do sine of angle A, which we don't know, over side A, which is 7.5. Then the sine of angle B, which we don't know, over side B, which is 17.9, equals the sine of 95.85 over side C, which is 20.1. Okay, I'm going to try to save a little bit of time here. You will just cross multiply. I better keep going. Okay, 17.9 sine of 95.85. And then we do divide both sides by 20.1. So let's type all that in. 17.9 sine of 95.85 divided by 20.1 gives us that. Now that's equal to sine of B. So again, since we need to solve for the angle, we have to use arc sine of that answer. And we get 62.36 degrees. So now we have two angles. We have B is 62.36. We have C is 95.85. So since we have two of the angles, the quickest way to solve for the last one is to subtract those two from 180. So if we do 180 minus those two numbers, we get that angle A is equal to 21.79 degrees. Whew, I know, those are long problems. Next ones are quicker. 34. Find the amplitude of the given function. Remember, the amplitude is just the coefficient out front, but it is the absolute value of that, meaning it's just positive 2/7. Find the period. Remember, we do 2 pi divided by b, and b is the coefficient in front of the x, or the theta, whatever our variable is, and that's 1/2 theta that's in front. So the thetas cancel out, leaving us 2 over 1/2. And to divide by a fraction, we multiply by the reciprocal, which gives us 4. So the period is 4. Okay, write an equation of the sine function with an amplitude of 9 and a period of 6. Okay, amplitude is 9, so that goes out front. We'll do y equals plus or minus 9 sine. And then to figure out the b value, that's the coefficient for x, we do 2 pi over the period, which will reduce to pi over 3. And don't forget to put a variable in there, x or theta or t, any of those is fine. But we have plus or minus 9 sine of pi over 3x. Same process here, except we're doing cosine. So we'll do y equals plus or minus the amplitude, which is 7, cosine. To get b, which is the number in front of x that'll go inside the parentheses, we do 2 pi over 3 pi. So because you do 2 pi over the period, the pi's cancel, leaving you just 2/3. Alright, now we're given the equation 53 cosine 5 theta plus pi minus 4. And we're asked to state the amplitude, the period, the phase shift, which is the same as the horizontal shift, and the vertical shift. The amplitude is 53, because that's the coefficient out front. The period is 2 pi over the coefficient in front of theta, which is 5. Okay, to get the phase shift, we see that it's plus. That tells us it's to the left. And we need to do c, which is this number, over b, which is this number. So it's shifting to the left, pi over 5. And vertical, we can tell by that sign right there, it's shifting down. And we know by this number, it's shifting down 4. Now, we're told the temperature in an office is controlled by an electronic thermostat, and the temperature varies sinusoidally according to this function. So part A, what is the temperature of the office at 7 a.m.? We noticed it's hours past midnight, so 7 a.m. would mean x equals 7. So we're just going to plug this into this equation. 72 plus 4 sine of pi over 12 times 4 minus pi over 3. Now, there's one thing I have wrong here. I'm still in degree mode, and I need to be in radian mode. So let's change the mode to radian. Just so you know, I will alert you on your exam what problems need to be degree and what need to be radian. And we get, oh, sorry. Let me try that again. For some reason I plugged in a 4 instead of a 7. It is 7 a.m., so plug in 7. Sorry about my mistake there. We get 74.83 degrees, or 74.828 degrees. Please don't round that to a whole number. Temperature can have a decimal. Okay, max and min. We know the max is equal to the midline plus the amplitude, which means 72 plus 4, or 76. The minimum is equal to the midline minus the amplitude, which means 72 minus 4, or 68. Okay, I believe this is the final trig question. You're riding a Ferris wheel with a radius of 40. When the last seat is filled and the ride begins, your seat is at the top of the ride, which is 95 feet above the ground. So let's pause here. We know now that the maximum is 95. And if we think about it, we know the radius is 40, so the distance down is also 40, making the total diameter or height of the Ferris wheel is 80. So for this top part to be 95 feet above the ground, we just need to do 95 minus 80 to figure out this is 15 feet above the ground. So 15 is then our minimum. We can use those to find our amplitude. 95 minus 15 over 2. It's going to give us 40, because you do max minus min over 2. And our midline is 95 plus 15 over 2. Gives us 55. And then we can talk about our period to find B. So let's go on. This says the wheel makes 1 revolution every 33 seconds. Well, that tells me the period is 33 seconds. And B is equal to 2 pi over 33, because it's always 2 pi over the period. Now we need to see if there's any kind of horizontal shift or phase shift. It says that when the ride begins, your seat is at the top of the ride. So at the beginning, you are at the maximum. We're starting at the maximum, so we don't have to do any shifting. You don't have to do a C value at all. So we have all of our information here. We'll do 40. Since we're starting with the maximum, we use cosine of 2 pi over 33. T, close the parentheses because there's no C value, plus 55. Whew. And that is all the trig problems.